Hey guys, it's primary and secondary tutorials here today. I'm going to show you how to prove an inverse by using composition of functions. So we're going to use the equations from yesterday's videos and we're going to prove them, like I said, through composition of functions. So here we have f of x is equal to 5x plus 7 over 4. We got to find the inverse. We went over that yesterday, so we're just going to do that real quick. We switch our y's and our x, so now we have x is equal to 5y plus 7 over 4. Now, we're going to do system equations. Get rid of this 4. You multiply 4 on both sides. Now we got 4x is equal to 5y plus 7. Now, minus 7 on both sides. Get rid of the 7. 4x minus 7 is equal to 5y. Since it's times 5, we're going to multiply everything by 5. So now, our inverse is going to be f inverse of x is equal to 4x minus 7 over 5. So now, let's prove this. How do we know for sure that this is an inverse of the equation we are given? So, what you're going to do is you're going to put this into the x. You're going to put your inverse into the x of your equation. So what does that look like? Well, it's going to be 5 times 4x minus 7 over 5 plus 7 over 4. And you're just getting things to cancel out here. And I'll show you what your answer should be very shortly. We're going to get this figured out. So our 5s are going to cancel out. So now we're going to have 4x minus 7 plus 7 over 4. Our 7s cancel out because negative 7 plus 7 is equal to 0. And 4x divided by 4 is equal to 1. So our answer is just x. And that will be your answer when it is an inverse. So what's another way that we could prove that it's the inverse? Well, here, let me show you. This time, you're going to put your equation into the x of your inverse. So what does that look like? Here, we're going to do it in the top right. So it's going to be 4 times 5x plus 7 over 4. Minus 7 over 5. The 4s are going to cancel out. So now we're going to get 5x plus 7 minus 7 over 5. And just like the last one, the 7s cancel out. And 5 over 5 is just equal to 1. So now you're going to get x. And you notice both have equaled to x. And that is how you can prove that those inverses are actually the inverse of your equation. Most algebra teachers or algebra 2 teachers are just going to teach you to do that first way I did it. But the second way is like a fact check, a proof, a double proof. Here we have the first equation from yesterday's video, and again we're going to prove it through composition of functions. So we have f of x is equal to 3x minus 5 over 2. Let's get the inverse. We're going to switch our signs. X is equal to 3y minus 5 over 2. Multiply both sides by 2. 2x is equal to 3y minus 5. Subtract the 5 from both sides. Or add the 5 to both sides, actually. 2x plus 5 is equal to 3y. Divide both sides by 3 to get the y by itself. And so now, we're going to bring it up here. And so our inverse of x is going to be 2x plus 5 over 3. And just like with the last one, we're going to put our inverse into our original equation. So, what will that look like? Well, it's going to be 3 times 2x plus 5 over 3 minus 5 over 2. Our 3's are going to cancel out. So, that leaves us with 2x plus 5 minus 5. And these parentheses are optional since you have nothing in front of the parentheses to distribute into the parentheses. These 5's cancel out. Now you're left with 2x over 2 is equal to x because the 2's cancel out. Now, let's do it the other way. Let's put our equation into our inverse so we can prove it again. So, it'll be 2 times 3x minus 5 over 2 plus 5 over 3. Our 2's cancel out. So now we have 3x minus 5 plus 5 over 3. Our 5's cancel out because negative 5 plus 5 equals 0. So now we have 3x over 3. 3 divided by 3 is 1, so we're left with x. And again, this proves that it is in fact the inverse of the equation because you get an x from both ways of proving it. Thank you very much.